Okay, this little gizmo was originally something called a 4M smart cleaner. And it's just a toy, and it's supposed to be like a little kind of like little floor sweeper. But it turns out that it kind of does an okay job with dust bunnies and stuff. So it's actually almost an appliance. The problem with it is that it would get stuck easily. So I thought, if there was a way to make it just a little bit smarter, it might not get stuck as much. So my goal was to intercept the AA batteries that were providing power to this little gizmo and then reverse them back and forth, because the motor can go in both directions. So in order to do that, what I did was I got a little seedy spindle case to act as a little cover for all the new parts I was adding. I put in a NanoPi NEO2 SOC made by FriendlyElec. It's really just a Raspberry Pi style board. It doesn't have Wi-Fi, so I put in a USB Wi-Fi dongle there. Then I got a charge controller from a USB portable charger that had busted on me. So I decided to scavenge it. And it's also got a 650 milliamp battery that it can charge, and which supplies power to the NanoPi. And it also has a mini DC motor driver module that's similar to the L298N module, but it works for lower voltages. And then there's a couple of Lego parts for structure. Now, what I'm going to do is show you a demo. The original gizmo would only do rotate in the counterclockwise direction or rotate left. So we'll try that on this little web page. And over here on the side, I've got a script running on the NanoPi showing that I'm executing the left rotation. So let me try to stop it. And then if I rotate right, you'll also notice that the motor sounds louder because the gears are going the other direction. But you'll see in both cases that it's gotten stuck. So what I'm going to do is I'm going to stop that. And what I did was I implemented a script. All it does is it rotates left for a random number of seconds, and then it stops, and it rotates right for a random number of seconds. And you'll see that now. Now I'll try to stop it. Oops. Let's see. Okay, now it's finally stopped. So overall, the problems I had implementing this was that because I didn't use a pure Raspberry Pi, it was just more difficult to get it up and running, but it does run really well once it's running. And the other part about this is that obviously this is a toy, so the gears in this thing will eventually fail. but I've kind of proven its functionality, so I'm pretty happy with it. Now in the future, if I wanted to make it easier, what I would probably do is start with a Raspberry Pi 0W, maybe get a bigger battery than the 650 milliamps so it stays alive longer, and maybe some kind of like accelerometer or some kind of multiple access circuit to see if I can figure out where it's located. Because if I know where it's located, or I know that it's, I wanted to see if it would be, I'd like it to be able to, you know, if it really gets stuck, to try to figure out some kind of strategy to extricate itself. And then maybe a camera for seeing where it is, which would also need a bigger battery. This could be a custom 3D case, and that's about it. But overall, it's a win.